So let's start with the NP chart. Okay. So NP chart is to be done on defectives. Okay. So you see here, I have the data on a period of time. I have the subgroup size, which is constant. Okay. And I have defectives. So when I have defectives, constant subgroup size, and over a period of time, I will use an NP chart. So I copy this data. I go to mini tab, I paste it over here. So I want to use an NP chart. I go to stats, go to control charts, go to attribute chart. Okay, because attribute is one we are referring to. And I will click on the NP chart. So in the variables, I will mention the defectives that we have. Okay. And in the subgroup, I would mention the total number of subgroup, which means total number of things which I have measured. So in this data, it says in January, there were 1941 was the volume, and out of that 12 defects were there. In February, the same number of volume, and we have 20 defects. Now the control chart, the NP chart, which is one of the control chart, will tell me whether this data has any special cause variation or not, which means whether my data is within my upper control limit and lower control limit. Okay. And I also want to do it on a period of time. So I go to scale, I go to stamp, click here, click on the month, because I want to look for month on month. Okay. So once again, click on scale, go to stamp, click here, click on month, click on OK, click on OK. And here the control chart is being prepared. So you see, this line is the average. Okay. The average of all the defects that we had. This is my lower control limit, which is 7.26. And this is my upper control limit, which is 34.54. Okay. All these data points that you can see, there is some amount of variance. Okay. In these data points, but all these are normal cause. This one data point, which is outside the control limit, 34.54 was the maximum. And this data point, let's click here. It says it failed. Okay. Because this is outside the control limit. So which means for the month of June, there is a special cause which is being observed. So let's look at it here. So in the June, you see the defectives were 36. So as compared to the entire data points that we have, it says 36 is coming up as a outside control limit. So now the action is to try and identify that what happened in June. Due to that, we have maximum number of defects. The rest other data points that you can see from January till July, barring this data point, June, all the data points are within control limits. Okay. So this is what my control chart tells me, that what is my lower control limit, what is my upper control limit, and which data point or which action which is outside control limit. So outside control limit are the special causes which are highlighted with red. You can see it below the line also. If there would have been any defects which would have been lesser than 7.26, this could have shown a special cause here. Line would have gone down. So this is what we do it for the NP chart, when my subgroup sizes are constant throughout the data that I'm capturing, and I have defectives. Is it clear to all of you?
Yes.
So LCA, can you again tell me how did we arrive at them?
How did
we arrive at the lower control limit and upper control limit here?
Number of control, you said how the UCL and LCA was calculated.
Yeah.
This is a data driven. This is being calculated by data itself. Though there might be some formulas towards it.
Yes, sir. Simmer, for the upper control limit, the formula is mean plus under root of NP1 minus P. So in case of a binomial distribution, we calculate the standard deviation using formula under root of NP1 minus P. So when you will add that to the average, you will get upper limit. When you will subtract that from the average, you will get lower limit.
Great, wonderful. So there is a different formula for different type of control chart we have. If you cannot use the same formula for the NP chart or C chart or U chart, okay? But we always need to remember that this is basis the data that has been populated. This is basis the average and the standard deviations that we have. We will never be calculating it manually because this is being captured by the tool itself. This will never be wrong, and this just gives me indication that which of the data points which needs to be worked on. You can Google it, you can research it, and find the formula for each of the control charts. But I believe it is not required to be known because it's clearly visible here.
And this Minitab uses the same formulas to calculate.
So it is so Minitab automatically calculates it.
Yes, Minitab automatically calculates it. So this has been calculated by Minitab. We just put in the data here, and Minitab has calculated. So when you see the other 6 types of control charts, you would see the UCL and LCL are being calculated automatically. We don't have to do anything here. It happened in fraction of seconds. Okay, so this was the NP chart. Now let's do the P chart. Okay, so P chart is also to be done for defectives, but here the difference is that these volumes, the total number that you measured is change. Yeah, are non-constant. Yes, absolutely. These are changing. So I just click here, copy this data. I go to Minitab. So I have from January till October, I have how many data points were actually there, like how many units were produced, and out of that, how many were defectives. I have the data here. Okay. Now I want to establish whether this data is within the control limit or outside the control limit. Okay. So I go to stats, I go to control charts. I again go to attribute. So earlier I clicked on the NP, now I click on the P. So don't click on P chart diagnostic or LANI-P, it's only P. In the variable part, I will mention the defectives because this tells me that how many defectives that we have got. In the subgroup sizes, I will mention the total volume that I have. Okay, so I'll mention the subgroup size here. I go to scale, I go to stamp, I go to stamp column here and mention the month. I click on OK. I click on OK once again. So here you see, this is the average proportionate that I've got. Okay. This is being calculated, which is defectives divided by subgroup. Okay. That is the average of average. This is my lower control limit, which is 0.0036, and upper control limit is 0.0619. And you see, these are the data points that we have. Okay. These are the proportions that we have. And you see, none of the data points are outside the control limit, which means this particular process is running smoothly, wherein we have captured it for some time. And though there is some variation, you see here, which is above the proportionate, but which is not above the upper control limit or the lower control limit. So we would conclude that this process is within control. It is showing the result which it's supposed to be shared, because the system has automatically calculated the UCL and LCL. And I would conclude that my P chart for defectives from January to October is good to go. I don't have to worry about it. However, if you really want to play with this data, you just mention the number of defectives as higher than that somewhere, and you would see it. So let me show you.
Simarpreet, one question. For the control charts, normally we look for how many months to come to some kind of conclusion that the process is doing good or whatever?
So typically control phase is for 2 to 3 months, depending upon the criticality of the situation that we are working upon.
Okay.
However, it may vary from 3 months, maybe sometimes 3.5 months also. So in that ways, we will have to monitor during that point in time. So you can break the data into number of days. It means you can capture the data on a daily basis. You can do it on a weekly basis. You can do it on a monthly basis as well, but not on a monthly
Right.
basis. Not on a monthly basis. This is just an example that I'm showing you, because if you are doing a project and the control phase is only for 3 months, then you will only have 3 data points, and then Minitab will not be able to show you the results. So you should at least
Right.
have 8 to 10 data points to conclude. So in that case, break the data into week or maybe into days to show
Okay.
the interpretation. Okay.
Okay.
So I
Yeah.
have, so great. So I have just changed this data. Earlier it was 36, and I want to see whether this is outside control limit or not. So I go to stats, I go to control charts, attribute charts, NP chart. Effective there. So I'm just changing the data. That's why we're doing it again. Subgroup size. So you see there. Okay. So it is because so it is very simple and easy to prepare control chart. You can learn it from YouTube also. You can learn it from Google also. It is not that difficult. But the after effect, which is that what in case if there is a special cause, that is something which needs to be understood. That is something which needs to be analyzed and identify that what is that special cause, because it has come in September. This peak can come again also. Okay, this can come in November, December, or January also. So nowadays, when the corona positive results are being captured, there are a lot of control charts are being used. Okay, they are not only checking whether this particular peak has come or whether this can come again also. So they are monitoring it using different control charts to predict whether this is going to happen in the upcoming weeks, upcoming months. So you would see certain articles coming up wherein they are measuring this. So this is a perfect tool to predict that what are the data points, what are the upper control limit or lower control limit, which is going to have in the future, which would have a limit. So